Okay. So that is the first thing. We have seen that the fatigue class depends on the material and the material yield. And now we are going to discuss the rest of the types. So the stress direction, the whether something is welded or not, and stress concentration factors, and they all are taken into account in one way or another. The 13001 and the Eurocode 3, they have for we had, if you remember, for non-welded parts, you can have fat classes over 200 easily if you have higher yielding. But if I see here for welds, I do not see that material anymore, and that is because of the reason I just explained to you before. Because in the welding procedure, I do get some local stress concentration factor. My weld tips are always under tension, and I have already initial cracks. These three take result in that the fatigue limit is not based on the material but just on the welding process itself. And you can see also here though that there is a big influence of quality, and that's, again, I hope that the Eurocode 3 will get into this detail as well. You can see here that depending on the stress direction, of course, the best. If I have a weld, let's put it this way. I have a crack here, maybe initial crack, and if I make this in 3D, the crack direction, the crack direction is this direction. So the most vulnerable stress variation is perpendicular to my weld. And you can clearly see that in the difference between this situation here and this one over here. So if the stress is along the weld, then basically the stress is going with the crack location, and basically the influence of that weld is fairly limited. You have a high number of a fatigue limit, so you have a high fat class, even 180 if you have a continuous weld quality level B. That is the best quality you can get, except you have one here which is B star, so that is basically B plus polishing and full inspection. So the nice thing is also these weld qualities are also specified in the standard. So if you follow a certain weld procedure, you can state that in your factory or workshop you produce a certain quality of welds, and that results into a fatigue class I can take into account. Yeah, so what we see here is two things. Is stresses along the weld have a much higher fatigue class compared to stresses perpendicular to the weld, which makes sense, of course. And what we also see is that shear limits, shear is not does not cause a lot of fatigue, and the reason of that is, although this is a lower limit, of course, but if we take the equivalent stress, then the difference between tau and a simple tension stress is times the square root of 3. So if I have a fatigue limit of here for 112, I need to multiply that with 1.7. Yeah, so the vulnerability, if we compare this into an equivalent stress for shear, is lower than for stresses perpendicular to your weld. Okay. This is of course also valid for other standards. The DMVGL uses different method. They have a W3 class for stresses perpendicular to your weld. Oops. And for stresses along the weld, you have a C1, which is a much better class. So you need to use here. Oh. And so C1 compared to W3, which is one of these lower ones. Yeah, so what I want to state is every standard uses these differences in stress direction. They do take that into account, but they use different FAT classes and yeah, they have different curves, but the idea is always the same. And then we have the FEM standard. That is the old crane standard. I don't know if you used to them, but for hoisting appliances, lifting appliances, the DMV, the older codes, they refer to the FEM, and they use, instead of these instead of FAT classes with a number, they do use names, but not the names from DMVGL. They make a difference between not welded, that is a W, and a welded specimen, which is a K class. And depending on the quality of your loss of your weld, you have the best quality is A0. If you have some and then it goes for non-welded. So non-welded, the one W1 is, I think, with holes and bolts, and W2 is if the quality of the edges of these of the holes of the bolts is below a certain level. Yeah, so there is some classification also in the W direction, but for welds you can see that depending on the stress variation, I get a lower or a lower class depending on the stress direction. Yeah, and you can see also here, if I improve my quality, I can go up a class. And so if I grind it, I can get from this detail to this one, which is grinded. If I do full penetration and grinding, I have K1. And if I have a detail not like this but like that, and I add the type of stress concentration is also there. Yeah, but you see also here, every standards reproduces the effect of the stress direction and the weld quality in a different way.